Hey everybody. In this video, we're going to talk about examining the relationship between two categorical variables. Just a reminder, categorical variables could be either nominal, unranked variables, or or ordinal variables. So there's some sort of ranking to um, the categories. We're going to begin by looking at creating a table, which we've done in the past. We use the table function, but we are going to add a second variable to it. We can assign that variable any value, just like we had in the past. I'll retype it. We'll call it v table, and we'll assign it the value of a table of two variables that we put together. Let's take a look and examine the relationship between patients' sex and whether or not they return to the hospital within 30 days. Let's just begin by putting gender and return 30. And notice that there is a comma between each of these. And when we run this, you'll see that vtable has values in it. And when we click run, I just put vtable here so we could display the contents of that vector. And we see that there are 50 females who did not return to the hospital, 14 who did, 83 males who did not, and 14 who did. And now notice in this table, the rows are the gender variable. So if you go across, those are rows. And so we put the row variable here and the column variable here. Now, again, it does not matter, by the way, what you put where. It doesn't matter at all because the counts will come out however they do. In fact, I'll demonstrate that to you now. I'll just put return 30 and whoops, gender, will reverse it just so you see that. And of course, now we just overwrote vtable, so when we run it again, you just see that this is flipped. It doesn't actually matter what order you put it in. When we use the next function, I'm going to suggest that you put the variable that if there's more than one, if there's a lot of categories for one variable, I'll suggest that you put them in the rows because it's easier to read, but it doesn't really matter what you do. Okay, so the next thing we're going to do is just like I showed you before with grouped box plots and so on, how to visualize things. We can visualize the relationship between two categorical variables with something called a mosaic plot. So the command is this, mosaic plot, and we just put the vector that holds the table in it, and then we can put a main label in it. So we will put in patient sex by readmission. Now it's very interesting because, like I said, for the table, the return 30 is in the rows and gender is in the columns. But when you get to the mosaic plot, it flips. So the gender of patients will be in the rows, which will be the y-axis. So we're going to put in the y-axis. We may be wrong with this, but I don't think I am. Y label be sex, yep. And we'll have readmission within 30 days. We'll just do readmit here. And we'll have yes and no. And then our main label will be, we have patient sex by readmission. We're all good. Let's hit run. And here, we'll stretch this out. Yeah, we did this correct. I remembered it correctly. Of course, if this was mislabeled, then we would have this incorrect. But we have sex and we have male and female. and we have readmit, no, and yes. So we can see that the yeses are evenly split between males and females. Um, so the females are at the top, the males are at the bottom. And we saw this in the table no matter how you looked at it. For those that returned, they were evenly split between males and females. The largest group, though, that we have are males that did not return. And the smallest group, like I said, by the size of the box, are either males or females who did return, and the next smallest group or the middle group would be females who didn't return. We see from this that there are fewer females in our sample because these two boxes represent all our females, these two boxes represent our males, and of all our yeses and nos, we see that the minority of patients were returned within 30 days. So we may want to get a bit more information about that, and so we're going to use a package called gmodels. So you're going to want to make sure that your gmodels box is checked. I've just checked it again for you so you could see it. And again, just like the table function, it doesn't matter which variable you put in the rows and which you put in the columns. But what I'm going to tell you is there's a lot more output that you're going to see in a moment from the CrossTable function. So it seems to be easier to read, from my estimation, if there are more than two categories, or the variable with more categories should go in the rows. It'll just be easier to read. But gender has two categories, and our variable return 30, which we're going to put in here, also only has two categories. So it doesn't matter in this case. By the way, this is called a 2 by 2 table because there are two rows, 1, 2, yeses and nos, and two columns. And we'll talk about tables that are larger than 2 by 2, but probably not today. So I'm going to run this function. It's, again, the function called CrossTable, all one word, capital C, capital T, the rest is lowercase. And we have a lot of information here, but I'm going to make this a little smaller so we actually have a key, much the way you would have a key for a map. So each of these boxes here in the female and no, these all are called cells. And we have totals, row totals here, we have column totals here. But there's, as you can see, there's lots and lots of numbers in each of these rows. So I'm going to go over what the key tells us. And the first is the N. So the N is the number of observations in those categories. And this is not new information. You actually had this information when you just ran the table function itself to create the mosaic plot. However, this is going to give us a lot more information. So we see that we have 50 females that did not return, 14 who did, and this row total tells us of all the females, we have 64 people in our sample, and of all the males, we have 83 who did not return, 14 who did, and 97 total. Now, if we were missing data for any of these, you obviously, if you had the status of their sex, but not of whether they returned within 30 days or not, you would have missing data. Because you obviously, in order to put somebody in one of these boxes, you have to have full information for them. So we have 97 males in our sample who we have information about their returning to the hospital or not. By the way, of the females, or of the total sample, 39.8% of the sample is female. So it's 64 divided by 161. That's our 39.8%, or the proportion is 0.398. And we also have the proportion of men, which is 97 divided by the total number, 161. And our proportion is 0.602, which is 60.2%. So we did see, like in the mosaic plot, the largest group in our sample is males. So we're going to skip the chi-square contribution. That's not relevant right now. But the next row, the third number down, would be the total n divided by the row total. So what this is telling us in this third number is of all the females, because this row is females, of all the females, 78.1% were not readmitted and 21.9% were. So we know that, nearly 8 in 10 women were not readmitted. Same thing with the males, the third number down. However, of the males, 85.6 were not readmitted and 14% were. So this is all the same information, just sliced and diced differently. So if we're interested in sex, then we would look at rows. If we're interested in readmission, then we're going to look at the columns. So the column gives us the n divided by the column total. So the column total is this. This is saying 133 patients were not readmitted. And that means that 82.6% of our sample was not readmitted, whereas 17.4% were, which is a total of 28 patients. So we're going to now take this 50 and divide it by 133, and that's going to say of all the people who were not readmitted within 30 days, 37.6% were female and 62.4% were male. So a greater proportion of those not readmitted were male. And again, we saw this illustrated in our plot right here. And of the yeses, so this would be interpreting it this way. And of all our yeses, we're looking at it this way, we saw a 50-50 split. So the fourth number down tells us that half the patients who were readmitted were female and half the patients who were readmitted were male. So this really illustrates this quite well, okay? And then this last one is the n, the number in the cell, divided by the table total. So this is 161 patients. So if we take 50 and divide it by 161, this is saying in our sample, 31.1% of our sample were women who did not return. 8.7% of our sample were women who were readmitted. Now this is interesting. Just over half our sample, of our total sample, were men who were not readmitted. And again, 8.7% of our sample were men who were readmitted. So that's how you read these tables. And I just want to give you one more example, just to get a little bit of practice doing this. And so what we'll do is we'll look at gender and marital status. Like, are women more likely to be married than not? So, this will actually, marital status will be good because I'll give you more experience looking at a table that's larger than 2 by 2. So, okay. So let's go back into our script. And let's first start by creating our table, because we need to create the mosaic plot. And we will have marital. I think it'll be good to do this way because we can stretch it this way. And I'm going to run this. We'll overwrite our V table. And now I'm going to, so now we have these categories: single, married, widowed, and divorced. So we'll see those categories in our mosaic plot. So we'll have patient sex by marital status. And we will call our X label marital status. And what we're going to need to do is probably stretch this because we're going to have now 4 marital statuses. And we'll run that. And now this really gives you a sense as to the size of each group. And so our largest group, of course, are men who were married. Not very many people in our sample, by looking at this, are divorced. In fact, we can see there's 4 people, 2 males, 2 females. So again, we're blocked up here. Women are more likely to be widowed than men. That's probably because women may be older than men. And nearly an equal split between single folks, between females and males, with slightly more females, and we see that with the 9 and the 7. So let's take a look at our cross-table function, and what we're going to do is put in our rows the marital status, because it'll be easier to read. So we'll put marital here, and we'll put gender here, and we'll run that. And now you'll see why it's easier to read this way. Now, this cell is not going to be, if you have it going across, well, sometimes, I guess it doesn't matter. It really doesn't matter. I find it easier. So, again, the counts are the same as what you saw in the table function, in the vector that we stored. But if we are interested, let's take a look at if we're interested in marital status, that would be our 3rd number down, our 3rd entry in our cell down, so in each of the cells. So we do know that there are 16 single people in our sample, representing 10% of the total sample, 10.1%. But of all the single people in our sample, over half are female, 56.2%, whereas 43.8% were male. So let's take a look just at the married. You could do this for all of them, but we'll just do single and married. And we're going to look at married because that's the largest group. So of the married folks, just over 1 in 5, 22.1% are female, but 77.9% are male. And married folks make up nearly 60% of our sample. So that's useful. If we wanted to look at by sex, we would look now again at the 4th number down because we're interested in the columns. So males, of all the males, 7.4% are single. The same 77.9% are married. That gives us, that explains why this is our largest box. 12.6% of the men are widowed, and only 2.1% identify as divorced. So I guess the single must be single and never married. Men make up, like I said, 59.7% of our, it's the same 59.7. 59.7% of our sample, and women make up 40% of the sample. So hopefully you found this video helpful. And we're going to continue talking about cross tables again next week. These are also called contingency tables, by the way.